The purpose of this video is to answer the following question. Why are neutral objects attracted to charged objects? And to answer this question, we need to take a look at the fundamental concept of magnetism, which is that like charges repel and opposite charges attract. So as you can see in these drawn diagrams right here, there are two negative charges, and the arrows that are indicated are the forces that the object feels from the other object. So the two negative charges will repel each other, and these two opposite charges right here will attract each other. And this attraction has a special name for it. It's called a dipole moment. Basically, it measures the separation of the positive and negative charges that are felt within a system. The two types of neutral objects that we're going to be covering in this video are classified by their ability to permit charge. So we'll start off with the first material, which is called a conductor. And these allow charges to move freely. So when the electrons move in the outermost part of it, they can conduct electricity. For example, metals are very good at this because they consist of positively charged nuclei with electrons outside that aren't tightly bound to any one atom. Instead, the electrons are distributed uniformly throughout the structure and are not bound to a single nucleus. So that describes the electron cloud. So in this way, they can conduct electricity very well. And the second we're going to be talking about is an insulator, which does not permit charges to move freely. And this is the reason why. There's no pathway by which electrons can move through the solid because the energy required to mobilize the electrons is very large. So good examples are wood and glass. So the rest of the video is going to be determinant upon these two interactions with positive and negatively charged objects, such as charging by induction and other methods.
You have a positively charged object and a neutral conductor. So when you bring them close together but don't touch them, you're going to get a charge of induction where the negatives are going to come towards the positive charges and the positives will remain on the right, far away from these charges. And if you touch them, these electrons are going to move onto this positively charged object until they're both neutral and they will not attract anymore. So when you have a negatively charged object and a neutral conductor, and you bring them close together, you're going to charge by induction, which will move all the electrons farther away from the negatively charged object. And if you touch them, then the electrons from the negatively charged object will come onto the conductor, and this will give this a net negative charge, and will give this a net neutral charge.
So for this situation, we're going to be talking about a positive charge on an insulator. So if you have a positive charge next to a neutral insulator, if they're far enough distance away, there's going to be no reaction. Once you bring the insulator close enough so that it's touching, if you bring the object close enough so that it's touching the insulator, ultimately what happens is you're going to create a dipole within the atoms inside the insulator. So you're going to have a net charge that's negative on this side and a net charge that's positive on this side. And because it's not a conductor and electrons cannot move freely, the positive charge object will stick to the insulator and remain that way. So in this situation, you have a negative charge and an insulator. Ultimately, the same thing is going to happen as if you had a positive with an insulator. So if you have a negative object and your neutral insulator here, if you bring the charge close enough to the insulator so that's actually touching it, you'll create a dipole within the insulator. Now this dipole is going to be positive mostly on the left side and negative mostly on the right side. Because there are no free electrons, the electrons will not move to the negatively charged object, and so the object is going to stick to the insulator.
When I comb my hair, electrons move from my hair to the comb, resulting in a net negative charge on the comb. When I move my comb towards pieces of paper, which are a neutral insulator, the paper moves upwards towards the comb because of the force between the positive and the negative, and the paper sticks to the comb because paper is an insulator. Rubbing this plastic spoon with a paper towel results in a net positive charge on the spoon. When I move the spoon towards a ball of aluminum foil, the foil will be attracted to the spoon because it is a conductor. The moment the foil touches the spoon, electrons are transferred onto the spoon, which neutralizes the spoon, and attraction will be lost.